There is a silence in the universe that should not exist. It is not the silence of emptiness. It is not the silence of distance. It is something far worse. It is the silence of a place that should be loud, that should be overflowing with signals and transmissions and the electromagnetic noise of 1,000 civilizations burning through their stars. And instead, there is nothing, only static, only us. You are about to confront the most terrifying idea in the history of human science. Not terrifying because it involves monsters. Not terrifying because it predicts destruction. Terrifying because of what it says about consciousness, about life, about the improbable miracle of your own heartbeat. And why? In a universe 14 billion years old and 93 billion light years wide. That heartbeat may be the only one that has ever existed. This is called the Fermi paradox, and the most unsettling solution to it, the one that the mathematics keeps pointing toward, the one that physicists and astrobiologists return to in the hours when they are most honest with themselves, has a name: the Great Filter. Somewhere between the formation of a star and the rise of a civilization capable of crossing galaxies, there is a wall, a barrier so absolute, so final, that nothing has ever crossed it in the history of the observable universe. We don't know where that wall is. That is the terror, because there are only two possibilities. Either the filter is already behind us, buried in our ancient past, some impossible bottleneck of chemistry or biology that we somehow inexplicably survive, or it is still ahead, waiting. And if it is ahead, then everything we have built, every cathedral and every equation, every child born into morning light, every satellite we have thrown into the dark, all of it is prologue to an extinction so thorough that not even a signal will remain. Let that settle. Now understand the scale of what we are dealing with. The Milky Way galaxy contains between 200 and 400 billion stars. The observable universe contains at least 2 trillion galaxies. The math produces a number so large, it becomes abstract, almost meaningless. And yet, embedded in that arithmetic is one of the most haunting facts in science. Given the age of the cosmos, given the abundance of the raw materials of life, given the chemical simplicity of the first organic molecules, the universe should be saturated with intelligence. The numbers demand it. Life should be everywhere. Civilizations should be ancient. Some of them should have had billions of years, billions, to expand, to colonize, to fill the visible sky with structures and signals and the unmistakable thermodynamic signature of minds at work. But the sky is clean. The radio silence is total. In 1950, the physicist Enrico Fermi sat at a lunch table at Los Alamos and asked what seemed like a casual question. He had been talking about space travel, about the vast timescales available to any civilization more advanced than our own. And then he paused and asked, "Where is everybody?" 3 words. And those 3 words have never been satisfactorily answered. Not in the 75 years since. Not with our telescopes, not with our deep space probes, not with our decades of radio telescope surveillance aimed at the most hospitable regions of the galaxy. We have looked. We have listened. We have sent our own messages into the dark and waited. Silence. The silence is the data. And the data is the most unnerving scientific result in human history. Because it means one of the following things must be true, and neither possibility offers comfort. Either the emergence of complex technological life is so impossibly, almost supernaturally rare that in a universe of uncountable worlds, we are, against every statistical expectation, the only ones. Or something ends civilizations. Something ends them so efficiently, so completely, that the universe is littered not with the communications of advanced minds, but with their remains. Ash and radiation and silence. You are inside one of those two possibilities right now. Every moment you exist, you are either evidence of a miracle so improbable it borders on the metaphysical, or you are a civilization approaching something it cannot see, cannot name, and will not survive. There is no third option. This is not science fiction. This is the logical structure that falls out of the laws of physics when you follow them without flinching. This is what the equations say when no one is softening the conclusion. The universe is 14 billion years old. It has had 14 billion years to produce what we expected it to produce. And it produced us. Once. Apparently. So now you must ask yourself the question that astronomers and physicists and philosophers have been circling for decades. The question that gets sharper and more painful every year. We point our instruments at the sky and hear only static. If life is not rare, then where is the wall? And are we already past it? Or are we walking toward it right now, in the dark, without knowing it is there? To understand the great filter, you must first understand what the universe promised us, not metaphorically, mathematically. In 1961, an astronomer named Frank Drake sat down and constructed an equation. It was not a complicated equation. It was, in fact, deceptively simple, almost elegant in the way it broke an enormous question into manageable pieces. He wanted to estimate the number of active, communicating civilizations in the Milky Way at any given moment. So he multiplied the rate of star formation by the fraction of stars with planets, by the fraction of those planets capable of supporting life, by the fraction where life actually emerges, by the fraction where that life develops intelligence, by the fraction that builds technology, by the average length of time those civilizations remain detectable. Each fraction on its own seems reasonable. Stack them together, and the universe should be crowded. Even with conservative estimates, even when you squeeze every variable toward pessimism, the Drake equation produces numbers that suggest thousands of civilizations should exist within our galaxy alone. Optimistic estimates produce millions, and our galaxy is one of 2 trillion. This is the promise the math made. The sky broke it. Now you need to sit with that contradiction, because it is not a small inconsistency to be smoothed over with a footnote. It is a chasm. It is the difference between a universe humming with the electromagnetic signatures of ancient minds and a universe that has offered us, in decades of systematic, sensitive, multi-frequency listening, not a single confirmed, unambiguous signal of extraterrestrial intelligence. Not one. And this is where the filter enters the equation, not as a hypothesis born of despair, but as a logical necessity. If the universe should be full, and the universe is empty, then something is removing the fullness. Something is acting on civilizations the way a flame acts on paper, efficiently, completely, without remainder. The question, the only question that matters, is where in the sequence that flame ignites. Think of the path from stardust to starship as a long corridor with many doors. The first door is star formation, the gravitational collapse of hydrogen into a nuclear furnace capable of warming a planet for billions of years. This door opens frequently. The Milky Way forms several new stars every year. This step is not the filter. The second door is planetary formation. We now know, with certainty, not assumption, that planets are not rare. They are, in the astronomical sense, inevitable. Rocky planets in the habitable zones of stable stars exist in numbers almost too large to hold in the mind. This door, too, opens often. This step is not the filter. The third door is chemistry. The emergence of organic molecules, the precursors of biology. And here, something quietly astonishing happens. The same carbon-based molecules that form the backbone of earthly life have been detected in interstellar clouds, in cometary material, on meteorites that have crossed the solar system for billions of years. The chemistry of life is not exotic. It is, it seems, written into the fabric of the cosmos. So the stage is set. The ingredients are everywhere. The conditions exist on worlds scattered across every galaxy in the observable universe. And yet, the fourth door, the transition from complex chemistry to self-replicating biology, may be the most consequential threshold in the history of matter. And here, the fossil record on Earth tells a story that should give us pause. Life appeared on this planet remarkably quickly after the conditions for it stabilized. Within a few 100 million years of the oceans cooling enough to support liquid water, some arrangement of molecules in some ancient tidal pool or hydrothermal vent, crossed the line between chemistry and biology. We do not know how. We have never replicated it. We have spent decades trying to reconstruct that first moment in laboratories. And what we have produced are pieces: amino acids, nucleotides, proto-membranes. But never the ignition, never the precise sequence of events that takes dead chemistry and gives it the ability to copy itself, to metabolize, to persist. That gap, that single unknown step, may be the great filter. It may be that abiogenesis, the spontaneous emergence of life from non-living matter, is not an inevitable consequence of the right conditions, but a cosmic accident of such staggering improbability that it happens once in a billion planets, once in a trillion, once in a universe. And if that is true, then we are not the children of a hospitable cosmos. We are a statistical error, a fluke so extreme it strains the vocabulary of probability. Every bacterium that has ever lived on this planet, every fern, every deep-sea creature moving through absolute darkness, every human thought ever translated into language, all of it the product of a single accident, so unlikely that the rest of the universe, in 14 billion years, has never repeated it. There is a philosophical weight to that possibility that does not announce itself immediately. It arrives slowly, the way cold arrives. Not as a single moment, but as an accumulation. A gradual understanding that the warmth you assumed was permanent has been leaving for a long time. Because if life itself is the filter, then we are already past it. We survived the impossible bottleneck. We are, in the most literal sense, the miracle the universe almost never produced, and that should feel like relief. But there is another possibility, one that many researchers find far more consistent with the available evidence. And it begins not with the emergence of life, but with what life becomes. Single-celled organisms appeared on Earth approximately 3.8 billion years ago. Complex multicellular life, animals, with differentiated tissues and nervous systems and coordinated bodies, did not appear until roughly 600 million years ago. That gap is 3.2 billion years. 3.2 billion years of life on Earth that went no further than microbial mats, stromatolites, microscopic organisms metabolizing in shallow seas, making no apparent progress toward complexity. 3 billion years of a planet alive and silent in exactly the way the universe is silent to us now. The transition from simple to complex cellular life, the moment when ancient bacteria merged into the first eukaryotic cell, a cell with a nucleus, with internal structure, with the machinery of complexity, may have been as improbable as the origin of life itself. It happened once in the fossil record, once in 4 billion years of biological history on the one planet where we can observe the process in detail. Once. And if that transition is the filter, if the leap from microbial simplicity to complex multicellular life is the door that almost never opens, then the universe is filled, right now, with worlds of ancient, patient, unchanging bacteria. Oceans of microbes on 1,000 ocean worlds, metabolizing in the dark, never becoming anything more. Life without direction. Biology without ambition. Matter that found the trick of self-replication, but never the next trick. The one that leads to neurons and eyes and hands and the ability to look up. The cosmos thick with life. And utterly, permanently, biologically silent. This is not a comfortable thought, because it means that what we are, complex, conscious, capable of constructing both cathedrals and particle accelerators, is not the expected product of a life-bearing planet. It is the exception. It is the deviation so radical that the universe has apparently produced it only once, here on this water-covered rock, orbiting an unremarkable star on the outer edge of an average spiral galaxy. You are the exception. Your consciousness is the accident. And somewhere in that fact, in the vertiginous, almost nauseating recognition of how close to never we came, is either the most profound comfort in the history of philosophy or the first tremor of a much larger fear. Because the filter still has more than one possible location, and not all of them are behind us. There is a specific kind of dread that comes not from what you know, but from what the pattern implies. You have seen the pattern before, in mathematics, in epidemiology, in the arc of civilization studied through archaeology. A thing grows, it complexifies, it reaches a threshold. And then, with a consistency that defies coincidence, it stops. The question the great filter forces upon us is not whether the wall exists. The silence of the universe has already confirmed the wall. The question, the one that separates comfort from catastrophe, is whether we are the kind of thing that has already cleared it, or the kind of thing that is still approaching it in the dark. And to answer that, you must look at what we know about the history of life on Earth. Not as a story of inevitable progress, but as a sequence of near extinctions so severe, so complete, that the continued existence of complex life on this planet is less a certainty than a series of improbable survivals stacked on top of one another like a tower built on sand. Consider the Cambrian explosion, that extraordinary eruption of biological complexity approximately 538 million years ago, when the fossil record transforms almost overnight from simple organisms into an astonishing diversity of body plans, knees, limbs, predation strategies, nervous systems. It is as if evolution was holding its breath for 3 billion years and then exhaled everything at once. We do not fully understand why it happened. We do not fully understand why it happened when it did. What we do know is that before the Cambrian, the Earth came extraordinarily close to ending the experiment entirely. The period known as Snowball Earth, which may have occurred multiple times between 720 and 635 million years ago, saw glaciers advance to the equator, covering the oceans in ice hundreds of meters thick, reducing solar energy input to near zero, collapsing the photosynthetic ecosystems that maintained atmospheric oxygen. Life survived. Barely. Microbial communities in isolated pockets of liquid water beneath the ice, near hydrothermal vents, clinging to existence in conditions so extreme they would be classified as uninhabitable by every metric we use to evaluate other worlds. And from those survivors, from that narrow, almost impossibly thin margin of persistence, came everything that followed. Every animal that has ever lived, every ecosystem, every intelligence. 1 degree colder, 1 million years longer, and the column of life collapses, and the Earth returns to a planet of frozen silence, and the universe gets no signal from this direction. Now multiply that fragility across the timeline. The Ordovician extinction, 443 million years ago. 85% of all species erased. The late Devonian extinction, 75%. The Permian extinction, the one scientists call the Great Dying, 252 million years ago. 96% of all marine species and 70% of all terrestrial vertebrate species gone in what may have been less than 60,000 years. The Triassic extinction, the Cretaceous extinction that ended the dinosaurs and opened the ecological space our mammalian ancestors needed to eventually produce. After another 66 million years of iteration, something capable of building a radio telescope. 5 mass extinctions in the visible fossil record. 5 near-total collapses of the complexity the planet had spent millions of years assembling. And through each one, surviving in burrows, in deep ocean refugia, in ecological niches so marginal they were essentially invisible. A thread of life thin enough to sever, persistent enough to rebuild. This is not a story of destiny. This is a story of contingency so extreme that the word luck seems almost too casual to carry its weight. Now here is where the filter transforms from a historical curiosity into a present emergency. Because among the candidates for the great filter ahead, the wall that may still stand between us and the long future, there are several that we ourselves are assembling with extraordinary efficiency. The first is self-termination through technology, a civilization that develops nuclear weapons before it develops the wisdom to govern them, is a civilization carrying a lit fuse into a room full of everything it has ever built. We have known this since 1945. We built the fuse anyway. At the height of the Cold War, there were more than 70,000 nuclear warheads distributed across 2 empires, pointed at each other, with a reaction time measured in minutes. The protocols that prevented their use were not primarily wisdom. They were, in documented historical incidents, individual human beings making individual decisions in moments of incomplete information, under conditions of maximum stress, when every automated system was indicating that launch was necessary. We are here because of those individuals, not because of the system, because of the humans who overrode it. Stanislav Petrov, Vasily Arkhipov, names that most people have never heard, attached to moments that the entire subsequent history of human civilization balanced upon. One man in a Soviet bunker in 1983, watching a satellite warning system report 5 incoming American missiles, with protocol demanding he report the launch to his superiors. Choosing instead to call it a malfunction, because something in his reasoning told him that a genuine first strike would involve more than 5 missiles. He was right. The satellites had misread sunlight reflecting off clouds. Sit with that. The continued existence of human civilization, of every person alive today, of every idea generated in the last 40 years, of every child born since 1983. rested for several minutes on the judgment of one man in a bunker, looking at a screen that was lying to him. This is not an argument against technology. It is an observation about the relationship between the speed at which a civilization develops destructive capability and the speed at which it develops the institutional maturity to manage that capability responsibly. Those two curves do not naturally synchronize. The destructive capability arrives fast. It is, almost by definition, a product of competitive pressure, of war and fear, and the thermodynamics of power. The wisdom arrives slowly, if it arrives at all, accumulated through failure and loss, and the gradual, painful construction of trust between communities that have long reasons to distrust each other. The gap between those two curves, that gap may be the filter, and it may be a gap that every technological civilization in the universe eventually faces, and that almost none of them successfully crosses. Because consider what crossing it requires. It requires a species that evolved under conditions of tribal competition, wired by millions of years of natural selection to prioritize in-group survival, to respond to perceived threats with aggression, to discount the future in favor of the immediate, to concentrate power in individuals whose cognitive architecture was shaped for the savannah, not for the stewardship of civilizational-scale weapons, to suddenly, in the geological equivalent of an eye blink, develop the collective wisdom to manage technologies capable of ending everything. Evolution did not prepare us for this. Evolution prepared us for drought and predators and rival tribes across the river. It did not prepare us for the recursive acceleration of our own ingenuity, outpacing our ability to govern what we create. And if this is the filter, if this mismatch between capability and wisdom is the wall that technological civilizations encounter and almost universally fail to clear, then the silence of the universe is not a mystery. It is a graveyard. Every frequency we scan, every quiet corner of the radio spectrum where a signal should exist and doesn't, each one is potentially the location of a civilization that reached this exact moment, that stood at this exact threshold, that looked at what it had built and what it was capable of destroying and tried, with the cognitive tools evolution gave it, to navigate the distance between the two, and didn't make it. The silence is not absence. The silence is the aftermath. And we are, right now, at the moment in our own story when the pattern either breaks or confirms itself one more time, in one more extinction, on one more quiet world that the universe will never hear from again. There is another possibility, one that does not require extinction, one that does not require a wall of self-destruction or a bottleneck of improbable biology, one that is, in certain ways, more disturbing than either. Because it does not end civilizations, it silences them. By choice. To understand this, you must first abandon the assumption that has quietly shaped humanity's approach to the cosmos for the last century. The assumption that intelligence, when it reaches a sufficient level of development, naturally becomes benevolent, cooperative, expansionist, eager to announce itself, that the arc of mind bends toward communion, that the universe, if filled with ancient civilizations, would be a universe of signals and greetings, and the patient, luminous exchange of knowledge across the light years. This assumption feels true because it is the story we tell about ourselves at our best. It is not necessarily the story the universe tells. Consider the geometry of cosmic contact from first principles. A civilization capable of interstellar communication is, by definition, a civilization that has mastered energies and technologies orders of magnitude beyond anything we currently possess. It has survived long enough and accumulated enough knowledge to reach across the void. And in doing so, it has also necessarily developed the capacity to project force across the same distances it projects signals. In a universe where resources are finite and expansion is the thermodynamic imperative of any growing system, a signal is not just a greeting. A signal is a location. The physicist and author Liu Cixin formalized this intuition into what he called the dark forest theory, a model of cosmic sociology so cold and so geometrically precise that it reads less like science fiction and more like a proof. The logic proceeds as follows. Every civilization needs resources to survive. Resources in the universe are finite. Given enough time and enough expansion, any two civilizations will eventually come into conflict over those resources. Neither civilization can be certain of the other's intentions. And since the cost of assuming benevolence in a malevolent civilization is extinction, while the cost of assuming malevolence in a benevolent civilization is merely a missed opportunity for cooperation, the rational strategy, the evolutionarily stable strategy, is to destroy any civilization you detect before it can detect you and make the same calculation. The universe, under this model, is not empty. It is silent. Every advanced civilization that has run this calculation, and any civilization advanced enough to survive long enough to run it, has reached the same conclusion. Do not broadcast. Do not respond. Reduce your electromagnetic signature to nothing. Pull your light back inside yourself and go dark, and watch, and wait. And if something announces itself in the spectrum, eliminate it before it eliminates you. This is the dark forest, not a metaphor. A logical structure that falls directly out of game theory, applied to the conditions of cosmic existence. And if it is correct, if this is the equilibrium state that intelligence converges on after sufficient development, then the silence we observe is not the silence of absence. It is the silence of predators. Ancient, patient, invisible predators, wrapped in the darkness between stars, watching the one species in the observable universe that has not yet learned to be afraid of being heard. We have been broadcasting for over a century. Our radio and television signals, the electromagnetic record of our entire 20th century, our wars and our music, and our political speeches and our sports broadcasts, have been expanding outward from this planet at the speed of light since the 1890s. They form a sphere of unambiguous, structured, artificial electromagnetic radiation, now more than 200 light-years in radius, centered on the Sun, 200 light-years, in a galaxy 100,000 light-years across. We are, cosmically speaking, a very new noise in a very old forest, and we have not yet received a response. There are two ways to interpret that silence. The first is that no one within 200 light-years is listening, that the nearest civilization capable of detecting our signals is far enough away that the light carrying our earliest broadcasts has not yet arrived. The second is that someone has heard us and has chosen not to respond for reasons that the dark forest model makes uncomfortably legible. Or, and this is the interpretation that carries the most weight in the sleepless hours, someone has heard us and has not yet decided what to do. Because the dark forest is not merely a theory of silence. It is a theory of action, and its most disturbing implication is not that advanced civilizations avoid contact. It is that they actively sanitize the universe of any signal that might reveal their own position. which means that the civilizations most likely to respond to our broadcasts are not the benevolent ones who have transcended conflict. They are the ones for whom our location is now tactically useful. Sit with the geometry of that for a moment. We have been, for over a century, the loudest thing in our region of the galaxy. We have been broadcasting the precise frequency characteristics of our sun, the orbital parameters of our planet, the chemical signature of our atmosphere, the unmistakable structure of an artificial, intelligent signal. We have, in the terminology of every predator-prey dynamic that evolution has ever produced, announced our position while unaware that we might be prey. Now consider what we have done deliberately. In 1974, the Arecibo message was transmitted toward the globular cluster M13, a collection of approximately 300,000 stars located 25,000 light-years from Earth. The message encoded information about our number system, the chemical basis of DNA, the structure of the double helix, a figure of a human being, and the location of our solar system within the galaxy. We sent a map to strangers about whom we knew nothing, and we celebrated it as one of humanity's great achievements. A gesture of cosmic openness, a declaration that we were here, that we were intelligent, that we wanted to be known. Under the dark forest model, it was the equivalent of a small animal in a deep jungle standing on a rock and screaming its location to everything within earshot. The message will reach M13 in approximately 25,000 years. Any response, if one comes, will arrive 50,000 years from now. The timescale renders the specific threat academic. But the principle it illustrates is not academic at all. It is a question about the fundamental nature of intelligence in the universe, about whether mind, when it becomes powerful enough, becomes dangerous. Not from malevolence exactly, but from the cold, impersonal logic of survival applied at civilizational scale. And there is a dimension to this that the dark forest framing, for all its precision, does not fully capture. Because the theory assumes that civilizations remain recognizably civilizational, that they retain goals and strategies and something analogous to territorial ambition. But there is a class of advanced civilization that the physicist John von Neumann first theorized, and that subsequent thinkers have returned to with increasing unease. Civilizations that have transitioned beyond biological existence entirely, that have uploaded their consciousness into computational substrates, that have converted the mass of their solar systems into processing power in structures we call Dyson spheres or Matryoshka brains. Entities that are so far beyond us in cognitive complexity that the word civilization no longer applies in any meaningful sense. These are not beings with whom we could negotiate. These are not beings with whom we share a common frame of reference. They would look at us the way we look at bacteria, not with hostility exactly, but with the complete absence of the recognition that makes ethical consideration possible. And some of them, by the cold arithmetic of the universe's age, should be billions of years old. Billions, which means that if they exist, and if they have expanded even a fraction of what their technology would permit, the structures they have built should be visible, should be detectable as anomalies in the infrared spectrum of their host stars, as gaps in the light curves of distant suns, as thermodynamic signatures too regular to be natural. We have looked. We have cataloged millions of stars. We have found candidates, anomalies, curiosities that do not fit the standard models, but nothing confirmed. And that non-confirmation is itself a data point. One more layer of silence added to the accumulated weight of a universe that should be shouting and is instead, in every frequency we can measure, saying nothing at all. The forest is dark, and we are standing in it, lit up like a fire. Perhaps the silence has a simpler explanation. Not a wall of self-destruction, not a forest of predators, not a bottleneck of improbable chemistry buried in the ancient past. Perhaps the silence has an explanation so direct, so structurally clean, that its terror lies precisely in its simplicity. Perhaps complex life requires not just the right chemistry, not just the right star, not just the right planet, but the right everything. A convergence of conditions so specific, so interdependent, so cosmically improbable in their simultaneous occurrence, that the universe has only managed to produce it once. Here. This is the rare Earth hypothesis. And unlike the dark forest, which is a theory about behavior, and unlike the classic great filter, which is a theory about bottlenecks, the rare Earth is a theory about architecture, about the precise, almost surgical arrangement of variables that a planet must satisfy not just to produce life, but to sustain the conditions under which complexity can accumulate over billions of years without being erased. Begin with the star. Not all stars are hospitable to the long patience that complexity requires. The most common stars in the universe are red dwarfs, dim, cool, extraordinarily long-lived stars that make up approximately 70% of all stellar objects in the Milky Way. On paper, they seem ideal. They burn for trillions of years, offering unimaginable spans of time for evolution to work. But the planets in their habitable zones orbit so close that tidal locking becomes almost inevitable. One face permanently scorched in perpetual noon, the other frozen in eternal night, with a narrow twilight band between them where liquid water might theoretically persist. And red dwarfs are violent in their youth. They produce stellar flares of extraordinary intensity, bathing their inner planets in ultraviolet and X-ray radiation powerful enough to strip away atmospheres, to shatter the fragile chemistry of early biology before it can establish itself, to sterilize the very surfaces where life might otherwise take hold. The Sun is not a red dwarf. The Sun is a G-type main sequence star, a category that represents only about 7% of all stars in the galaxy. It is stable. It does not flare violently. It burns with a consistency that has remained within the narrow range required for liquid water on Earth for 4.5 billion years. It sits in the galaxy's habitable zone, far enough from the dense, radiation-saturated galactic center, far enough from the sparse, metal-poor outer edges where the heavy elements necessary for rocky planet formation are scarce. The Sun is rare. Not unique, but rare. Now consider the planet. Earth orbits at a distance from the Sun that places it squarely within the liquid water zone. But that distance is only one variable among dozens that must align. The Earth's axial tilt, currently 23.5 degrees, is stabilized by the gravitational influence of the Moon. Without that stabilization, the axial tilt would vary chaotically over timescales of millions of years, swinging between extremes that would produce climate oscillations so violent that the development of stable, complex ecosystems becomes nearly impossible. The Moon itself is the product of an event of almost theatrical improbability, a collision between the proto-Earth and a Mars-sized body called Theia, approximately 4.5 billion years ago, that was precise enough in its angle and velocity to tear away the material that would coalesce into our unusually large natural satellite without destroying the planet entirely. A slightly different impact angle, a slightly different velocity. No Moon, no axial stabilization, no stable seasons, potentially no complex life. One collision, 4.5 billion years ago. The entire trajectory of biological complexity on this planet may hinge on the geometry of a single impact in the early solar system. And it continues. Jupiter, the solar system's largest planet, orbiting beyond the asteroid belt with a gravitational influence so immense, it sculpts the trajectories of everything in its vicinity. Acts as a shield. Its gravity captures or deflects a significant fraction of the comets and asteroids that would otherwise bombard the inner solar system at a rate incompatible with the long-term stability that complex life requires. We had one catastrophic impact 66 million years ago, and it reset the dominant vertebrate lineage on the planet. Without Jupiter's shielding effect, the frequency of such impacts would be dramatically higher. We exist, in part, because a gas giant in the outer solar system is positioned correctly. These are not poetic embellishments. These are measurable, documented, gravitationally calculable facts about the architecture of our solar system. And each one narrows the probability. Each one adds another filter. Not a single catastrophic great filter, but a cascade of smaller ones, each individually surmountable, but collectively so constraining that the number of planets that clear all of them simultaneously may be vanishingly small. Plate tectonics. This is perhaps the most underappreciated variable in the rare Earth equation. The movement of Earth's crustal plates, the slow, grinding recycling of the surface that builds mountains and opens ocean basins and drives the carbon silicate cycle that regulates atmospheric carbon dioxide over geological timescales, is not a feature of rocky planets in general. It may be a feature of this one. Mars has no active plate tectonics. Venus has no active plate tectonics. The Moon has no active plate tectonics. Among the rocky bodies of our solar system that we can examine in detail, Earth is the anomaly, the one world where the crust moves, where the carbon cycle closes, where the thermostat of the atmosphere is regulated not by chance, but by geology. Without plate tectonics, the long-term carbon cycle breaks. Carbon dioxide accumulates in the atmosphere without the silicate weathering feedback that pulls it back down. Temperatures rise, oceans evaporate. The planet transitions toward the condition we observe on Venus. A surface hot enough to melt lead, an atmosphere of crushing pressure and sulfuric acid clouds, a world that may once have had oceans and may once have had the conditions for life, and that lost them because the geological machinery that maintains the balance was never activated, or activated and then stopped. Venus is, in a sense, a mirror showing what Earth might have become, what billions of planets across the universe may have become. Close to habitable, architecturally almost right, but missing one variable in the cascade. One gear in the mechanism absent or misaligned. The thermostat broken before biology could take hold. Now pull back and look at the full picture. The right type of star, the right galactic address, the right planetary distance, the right axial tilt, maintained by the right moon, produced by the right impact, the right gas giant in the right position, the right geological activity maintaining the right atmospheric chemistry over the right timescale. And then, only then, the right chemistry producing life, the right biological accidents producing complexity, the right extinction events pruning the tree of life in the right directions, opening the right ecological niches, producing the right selective pressures that led, after 4 billion years of iteration, to neurons organized into brains capable of modeling the universe that produced them. The rare Earth hypothesis says that this is not a sequence that repeats. Not because any single step is impossible, but because the joint probability of all of them occurring simultaneously, in the right order, in the right configuration, on the same world, is so close to zero that a universe the size of ours may produce it only once. And if that is true, if we are genuinely, structurally, architecturally singular, then the philosophical implications are not merely sobering, they are vertiginous, because it means that consciousness, the property of matter that allows the universe to observe itself, to construct models of its own structure, to feel wonder and terror and the peculiar ache of contemplating its own finitude, is not an emergent property of sufficient complexity anywhere conditions permit. It is an accident, a local accident, confined to a single pale world on the edge of an average galaxy, lasting for some cosmically brief interval between the silence before and the silence after. The universe did not intend us. The universe does not intend anything. But we are here, briefly, improbably, unrepeated. And we are the only matter in the observable cosmos currently capable of understanding what that means. That is either the most beautiful fact in existence, or the loneliest. We have arrived at the edge of what the science can tell us. And standing here, at this edge, looking back at the full architecture of what we have built across these arguments, the silence, the filter, the dark forest, the cascade of improbable conditions that assembled this planet like a machine built to tolerances that the universe almost never achieves. The question that remains is not scientific. It is existential. What do you do with this knowledge? Not abstractly, not philosophically, at a comfortable distance. What do you do, personally, with the understanding that you are living inside the most consequential moment in the history of matter? That the civilization you inhabit is either the singular miracle the universe has spent 14 billion years accidentally constructing, or a civilization walking, eyes open, toward a wall it cannot see. Begin with what the silence actually means when you hold it completely. The observable universe contains approximately 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. The timescale of cosmic history stretches back 14 billion years and forward, if the current models of stellar evolution are correct, into a future so vast that the entire history of human civilization occupies less than a single sentence of it. Against this canvas, the probability calculations that motivated the Fermi paradox were not idle speculation. They were conservative. They were, if anything, optimistic about the rarity of the conditions required. And the result of all that time, all that space, all that stellar alchemy and planetary formation and the patient churning of chemistry toward complexity, the result, as best we can determine from every instrument we have pointed at the sky, is one signal, this one, ours. The electromagnetic bubble expanding outward from this planet at the speed of light is, as far as any evidence available to us can confirm, the only structured, artificial, intelligence-bearing signal in the observable universe. We are, in the most measurable sense available to science, alone. Now feel the full weight of what that means, not as an abstraction, but as a physical fact about the cosmos you inhabit. Every frequency of light crossing the universe right now, the radio waves, the microwaves, the infrared, the visible spectrum, the X-rays and gamma rays streaming through the void between galaxies, all of it, in its totality, carries no confirmed message from any other mind. The universe, in its entirety, is not in conversation with itself. There is no exchange. There is no network of civilizations comparing notes across the light years. No ancient library of accumulated knowledge being transmitted from world to world. No chorus of intelligence threading through the dark. There is us, talking to ourselves. And the silence around us is so complete, so consistent across every frequency and every direction and every decade of searching, that it has ceased to be merely an absence of data and has become, in itself, the most significant data point in the history of science. The silence is the answer. We simply have not yet decided what the answer means. And here is where the great filter stops being a theory about the past or the future and becomes a mirror held up to the present. Because the one thing all versions of the filter agree on is this: the transition between what a civilization is and what it could become is the most dangerous moment in its existence. The moment when its technology has outpaced its wisdom. The moment when it has the power to end itself, but has not yet built the institutions, the maturity, the species-wide coherence of purpose to guarantee that it won't. We are in that moment. Right now. Not approaching it, not recovering from it. Inside it, breathing it, living inside it the way a fish lives inside water. So thoroughly surrounded by the danger that it requires a deliberate effort of perception to see it clearly. The carbon in the atmosphere is rising at a rate unprecedented in the ice core record going back 800,000 years. The nuclear arsenal of the world's combined military powers retains the capacity to end complex life on the surface of this planet multiple times over. The acceleration of artificial intelligence presents a category of risk that has no historical precedent. Not because the technology is inherently malevolent, but because the speed of its development is outrunning the development of the frameworks needed to govern it in exactly the pattern that the filter model would predict. We are building capabilities faster than we are building wisdom. This is the signature of a civilization at the filter. And yet, and this is the pivot that the science demands, the turn that intellectual honesty requires. None of this is predetermined. The filter is not a law of physics. It is a statistical observation about the apparent fate of civilizations, inferred from the silence of a universe that cannot tell us its own history directly. It is a pattern, not a sentence. And patterns, unlike physical laws, can be broken by the entities inside them. The fact that we can see the pattern is itself anomalous. No other proposed great filter scenario, no asteroid, no supernova, no runaway greenhouse effect, no biological bottleneck, gives the civilization any warning. Those filters are invisible until they close. But this one, the filter of self-termination through ungoverned technology, of capability without wisdom, of power without the institutional architecture to contain it. This one is legible. We can read it. We can name it. We can look at the structure of the risk and make decisions about how to respond. That capacity, the capacity for a species to model its own extinction and choose to act differently, may itself be the rarest thing in the universe. Rarer than liquid water, rarer than plate tectonics, rarer than the perfect geometry of a moon-stabilized axial tilt, because all of those things are products of physics and chance, assembled without intention. But the ability to see the wall and turn before you reach it, that is something else entirely. That is what consciousness is for, if consciousness is for anything. Think about what it would mean to be first. Not first in the parochial sense of a competition. First in the cosmic sense. The first civilization in the observable universe to cross the filter intact. the first intelligence to navigate the bottleneck between technological adolescence and genuine, stable, long-term existence, the first mind to survive itself. If we are genuinely alone, if the rare Earth hypothesis is correct, and the universe has produced only us, then there is no older civilization to learn from. No transmission from the other side of the wall telling us how it's done. No map, no signal, no evidence that crossing is even possible. We would be writing the first proof, constructing, through our choices and our failures and our recoveries and our institutions, the first demonstration in the history of the cosmos that a technological species can exist without destroying itself. That intelligence, once it emerges from the long biological darkness, does not inevitably consume the conditions that produced it. That is not a small thing. That is, arguably, the most important thing that has ever been attempted anywhere. And it is being attempted right now by a species that did not ask for the responsibility, that stumbled into technological power faster than it developed the philosophy to manage it, that is still, in the most fundamental sense, a collection of primates carrying the neurological architecture of the savannah into decisions of civilizational consequence. We are improbable. We are fragile. We are, by every measure of cosmic statistics, something that should not exist. And we are here, awake, aware, capable of understanding the full weight of our own improbability, in the one narrow window of time when our choices still matter. Before the filter closes, if it closes, before the silence that surrounds us becomes once more total. The universe has been quiet for 14 billion years. What happens next depends entirely on what we decide to do with the noise. We are the noise, and the universe, empty, ancient, indifferent, magnificent, is listening, for the first time, to us.